In this video, I'm going to show you how to implement array.flat method in JavaScript. Now this is a popular question and it's asked during many front-end interview rounds. So it's really good to have the knowledge of how to implement this method from scratch. So basically I'm going to implement the polyfill for the array.flat method. And not only that, once I'm done showing you how to implement the method, I'm also going to dry run the entire code to help you get a better understanding of its implementation. So without any further ado, let's get on with it. Now before implementing the array.flat method, we should first know how it works. Now if you want to know how to implement the polyfill for different methods, I'll put a link in the description, because in that video I've implemented 5 different polyfills and I've shown you the way to how you can approach creating polyfills for any method you want. So in this video as well, I'm going to follow the same approach. So if you want a better understanding of how to approach these problems, you can also have a look at that video that I'm going to link in the description below. So first let's just see how does array.flat work. So first of all, I'll create an array over here. Now let's say in the array I'll have 1, 2, 3, and then I'll have another array within the array, and that will include 4 and 5. And then after that I'll create another array, and within this array I'll have 6, 7, 8, and within this array I'll have another array that will have nothing but, let's say, 9, and then within this array I'll add another array that can have 10, 11, and 12. I'm going to save this. So you can see the structure of this array. First of all, we just have 1, 2, 3, and in the third index, which is the 4th element, we have an array which has 4 and 5. Then after that we have another array which includes 6, 7, 8, and then an array which includes 2 elements, which is 9, and another array 10, 11, 12. Alright, so now let's just see how does the flat method work. So what I'm going to do over here is I'm going to say console.log, and I'm going to say array.flat. Now as you can see over here, the flat method takes one argument, which is a number, and that is nothing but the depth. So what does the depth do exactly? What the depth does is, whatever number I specify here as an argument, the flat method will only flatten up to that depth that I have specified over here. So to briefly explain you what I mean, if I just put 1 over here within this flat as an argument, what's going to happen is, it's going to go within this array, and when it starts to flatten out, it's going to only flatten until one depth. It's only going to flatten until one level of the array. So what's going to happen is that in the resultant array, there's going to be 1, 2, 3, but then when it reaches this array, it's going to see that within this array, there is no other arrays present. This is only one depth. So it's also going to put 4, 5 within the resultant array. Then after it goes to this array over here, it's going to see that within this array, there are 2 more arrays. One is this and another one is this, right? So what one does is, one is going to say that I'm only going to flatten until one depth. So it's going to put 6, 7, 8 as well in the resultant array. But for these 2 elements, 9 and 10, 11, 12, it's just going to add this entire array. Now to show you what I mean by that, I'm just going to save this and I'm going to go to my browser. So now if I go to my browser, you can see what I get over here. I get 1, 2, 3, 4, 5, 6, 7, 8. And an array which has 2 elements, and those 2 elements are nothing but this 9 and 10, 11, 12. So if I open this up, you can see 1, 2, 3, 4, 5, 6, 7, 8, and then the last element has an array which includes 9 and 10, 11, 12. Alright, so that's what the depth does. Since I said we just want to flatten until one level deep, so one level means since this array is just one array, so it's going to flatten the entire thing. But this array contains 2 arrays, so it's just going to flatten these things. But as soon as it sees another array within this array, it says I have been told to flatten only one level deep, and I have flattened 6, 7, 8. But since you are another level deep, I'm just going to directly add you within the resultant array. So that's why it adds this entire array as a whole as the 8th element. And that's exactly what's happening over here. In the 8th element, we have 9 and an array which contains 3 elements. And those 3 elements are nothing but 10, 11, 12. Alright, so if I close this array, you can see 1, 2, 3, 4, 5, 6, 7, 8. And the last element is an array that contains 2 elements. And those 2 elements are nothing but 9 and the array 10, 11, and 12. So another thing that flat does is, if I leave this empty, then flat is gonna assume the depth to be 1 as default. So it is going to give the same solution that I just showed now. And if I make this 2, then what's going to happen is all of these are going to be flattened. But within this array, it's going to first flatten this, then it's going to flatten this as well. But then after that, it's going to say I have flattened 2 arrays within this array. Now when it stumbles upon the third array, it's going to be like, I'm not going to flatten this, because within this array I've already flattened these elements, and then I flattened this. So when this comes, it's going to be like, I've already flattened 2. Now you are the third depth. I'm not going to flatten you. So it's just going to add this array as a whole into the result. So if I save this and I show you the result, then as you can see over here, this time I get 1, 2, 3, 4, 5, 6, 7, 8, 9 and an array. And this array includes 10, 11 and 12 because this time we are flattening 2 levels deep. So when it reaches this array, the first level deep is going to be this, and then there is another array coming, so that's going to be the second level depth, and then within this it sees that there is another array, so this will become the third level depth, which is not possible to flatten because we have mentioned 2 over here. So it's just going to flatten 6, 7, 8 and 9, but for this it's just going to add the whole thing back into the result, and that is exactly what we saw over here. Now if I specify 3, then it's going to flatten the entire array into the result, because when it reaches this array, it's going to see that this has a 3 level depth. The first level depth is nothing but the contents within the main array, which is 6, 7, 8. Then within this array there is another array, and then within this array there is another array. So this is going to be the third level depth. When I specify 3, it's also going to flatten this array. So if I save this and I go to my console, then you can see it flattens everything, all the elements into one single array. So now this resultant array has all the elements within it. And lastly, another thing to take note of is I can pass something called infinity over here. So infinity in JavaScript is nothing but a number, and that number is just going to say flatten the entire array. So if I pass infinity, it's just going to flatten this entire array. So if I go to my browser, you can see in the console it still flattens the entire array, same as when I had passed the depth of 3. So this is all about what the array.flat method does. Now we need to create a polyfill that does exactly what we saw over here. So let's go ahead and create that. So what I'm going to do is I'm going to comment this out, and we need to create our own flat method within this array. So we are going to use prototypes. So if you don't understand what prototype does, in this case you don't quite need to go into the depth of it, but if you want to understand it better, then you can watch that polyfill video that I had created, which is linked in the description. But just to give you a small overview, I'm going to show you why we need it in this case. What I'm going to do is I'm going to say array dot prototype dot, I'm going to call my method as my flat. So the actual method is flat, but I'm going to create a polyfill, my own implementation of this flat function, and I'm going to name it my flat. Alright, and this is going to be assigned to a function. So what does array.prototype.myFlat do? What this does is, what prototype does in this case is, when I use array.prototype and whatever name I assign after that, this my flat is going to be attached to this array now. So what that means is, in the similar way I use array.flat, I can now also use array.myFlat, because my flat is going to now become a property of the array constructor. Alright, so this is nothing but an object. Functions are nothing but an object, right? In JavaScript, functions are an object. When I do array.prototype.myFlat, my flat becomes attached to the array prototype. When something gets attached to the array prototype, we can call it in this similar fashion. Instead of array.flat, I can do array.myFlat. So just to show you a brief example, what I'm going to do is, I'm going to console log array.prototype. Alright. So if I console log this, so you can see array.prototype is console logged, and within this array.prototype you can see a function myFlat, and this is nothing but the function that we created. You can see this as a function, and now if I scroll down, you can see all other methods of the array which we regularly use, which is fill, filter, find, flat, flat map, and all that. So when I do array.prototype and I assign a name after that, a custom name, what it does is it assigns that property to the array constructor. And once that happens, I can also use my function in the similar way we use array.map or array.flat and so on. So what I can do now is I can do something like this. This above statement over here gives me the power to do something like this. It lets me do something like array.myFlat. Alright, similar to how it was over here. So that's what this array.prototype.myFlat is going to do for us. Alright, so I'm just going to remove this for now. If you're still not clear, you should go and watch a video on how prototypes work in JavaScript before trying to implement the polyfill, because that's pretty important. But I assume you do understand what prototype does in this case. Alright, now moving on to the implementation. Now since myFlat is already registered within this array constructor and we can use array.myFlat, we are done with the initial part of creating a polyfill. Now let's go ahead and add the functionality to our myFlat function to make it work exactly like how it was working over here. So first of all, we know that array.flat takes a parameter over here which is nothing but the depth. We passed 1, then 2, then 3, and then infinity, and so on. So we know that this takes an argument of depth. So what I can do is I can say, let's say I'm going to pass a depth of 1. Alright, and then we know since this takes a parameter of depth and this myFlat is equal to this function, whenever we are calling myFlat, we are obviously calling this function because myFlat is equal to this function. So in this function, we are going to take an argument of depth. Alright, so this 1 is going to map to this depth. Pretty simple, right? So now after this, we are going to make use of this depth and we are going to implement the array.flat method. So first of all, one thing to remember is if I remove this comment, you can see that the flat method actually returns a new array. You can read over here, the flat returns a new array with all the subarray elements concatenated into it recursively up to the specified depth. So it returns a new array. That's one thing we need to understand. So whenever we flatten this entire thing, the entire flattened result is returned in a new array. So what I'm going to do first of all is I'm going to create an empty array. I'm going to name it flattened array. I'm going to initialize it to an empty array, and this is going to be returned in the end. So now the next thing to do is I'll create a function within this. Within this function, I'm going to create another function, and you'll see why. And I'm going to name it flattener because this is going to flatten our array up to the specified depth. And this is going to take nothing but 2 arguments. One is the array and the next is the depth. Alright. Now before we implement the logic within this function, I'll just call this function down here. So this flattener is going to take the array and the depth. Now the depth we already have that. But how do I pass the array? We are already getting the depth from here. So I can just pass it over here. But this is the second argument, and the first argument we need to pass the array. How do we pass the array? To pass the array, all we need to do is I need to write this over here. Now this is going to refer to this array over here, because if you know how this works, when I call array.myFlat, so whatever this myFlat is attached to, this is going to reference to that. So in this case, myFlat is attached to ARR, which is this array. So when I write this over here, when I write this within a normal function, this is going to represent whatever myFlat is attached to, and myFlat is attached to ARR. So this is going to be equal to this array. Alright, pretty simple. And if you still don't understand how this works, I'll also attach a video in the description where I've explained this keyword in depth. So now to the flattener, we are passing the array and the depth. Now within this, we just need to perform the logic. So what I'm going to say is I'm going to write a for loop, because we obviously need to go through each of these individual elements, right? So I'm going to say for const element of array. So we are going to loop through each element, 1, 2, 3, then this array, then this array. So for that, after that, what we're going to do is I'm going to perform a check. I'm going to say if array dot is array element and depth. Alright, then we want to do something else. What does this mean? So this just means that when I reach an individual element, we want to do something else, but every time I stumble upon an array, we want to do something else. So first of all, it's going to be pretty simple. Consider we are traversing through this array. So when I first reach upon 1, obviously 1 is not included within another array. It's just an independent element. So 1 can be directly pushed into this flattened array. 2 similarly can also be pushed. 3 also can similarly be pushed into this flattened array. So all we can do is flattened array dot push, and I'm going to push that element. Alright, so now this flattened array is going to contain 1, 2, and 3. Now don't worry if you don't understand this in depth now, because I'm also going to dry run this entire code with this example to help you understand it better. So what happens now is when it goes through each element, it sees that this is not an array, so it pushes it to the flattened array. Similarly, it does the same for 2 and 3, it pushes it to the flattened array. But then it reaches this array over here, and then it sees that array.is array of element. So the element this time is an array. So this part becomes true. Alright, and we're checking the depth, and the depth we passed in myFlat is 1, which is being passed here, and then from this flattener function it's being used within this flattener function itself. So this statement is going to become true for this array because it is an array, because this element is an array, and the depth is 1, and we know 1 in JavaScript means true, 0 means false, but everything else 1, 2, 3, 4 and all, they mean true. So it's going to see that for the element 4, 5, this is true and depth is 1, so 1 is also true. So if these two are true, it's going to do something else. So all we are going to do over here is we are just going to call the flattener function again, and we are going to pass the element and depth minus 1. Alright, I'm going to save this. Now this is pretty much all we need to do. We are basically recursively calling this flattener function again if the element is an array and the depth comes out to be true. Now don't worry, I'll try run this to you and you'll understand this perfectly fine. Now after doing all this, in the end we need to return this flattened array. Once everything gets pushed to the flattened array, we just need to return the flattened array. Alright, now you can see over here I'm console logging array.myFlat and I'm passing the depth of 1 for this array. So let's see if our own myFlat polyfill works or not first before I go ahead and dry run you this code. So I'm going to save this and I'm going to open my browser, and in the console over here you can see that I had passed a depth of 1. When I pass a depth of 1, when we were passing 1 in flat, it was flattening this part, but it wasn't flattening this part anymore because this was having a level of 3. So it just flattens this first level and it ignores flattening these two levels. So similarly for our myFlat polyfill in our browser console, you can see that we get the exact same output. Since we are flattening up to a depth of 1, you can see 1, 2, 3, 4, 5, 6, 7, 8, and this last element includes an array which has 9 and another array within it which is 10, 11 and 12. And since the depth is 1, so that's why it's not flattening these two arrays, but it's flattening until one depth of the last array which is 6, 7 and 8. And just to show you that this works exactly like that, I'm also going to uncomment this. So you're going to see that these two console logs are going to be the same. And just to be able to differentiate this properly, I'm going to name this myFlat, and over here I'll name this flat. Alright, so the first console log is going to be our own implementation of flat, and the second console log is going to be the actual flat implementation that was already present. I'm going to pass 1 over here as well. And let's see if the outputs are same. If I go to my browser, there you go. You can see myFlat and flat have the same output. If I expand this has 9 and the array 3 as the 8th element. And this also has 9 and the array 3 as the 8th element. Now just to be sure, I'll also pass 2 over here in both of them. And let's see if they are same again. I'll save this, go to my browser, and you can see they're the same again. So in 2, what happens? This has 10, 11, 12 as the 9th element. And this also has 10, 11, 12 as the 9th index element. Alright, and lastly I'll pass infinity over here and also do the same for this. So if we pass infinity, then it should flatten this entire array out. Let's see if that happens. There you go, you can see both the arrays are completely flattened out. Now one last thing I forgot to add is this depth should be initialized with 1, so that if we do not pass anything as an argument to our myFlat function, then it's going to take the default depth as 1, just like how flat works. So to show you that, I'll remove this. I'll also remove this. Flat takes a default depth of 1, and now our myFlat will also consider the default depth to be 1. Let's see if the outputs are same, and there you go, you can see both the outputs are completely same. Yup. Alright, so now we are done with the implementation of the flat method. We just created the entire polyfill for the array.flat. Now lastly, I'll just dry run this code to you for this example so that you can understand everything properly. I'll just comment out flat. And what I'm going to do is I'm going to copy this thing and I'm going to open up a whiteboard, and within that whiteboard I'll dry run this code to you. Now in this whiteboard, I have added the array that we had taken the example as, and I've also added the code that we wrote over here. So here I'm going to dry run you the code for the depth of 3. Alright, so what's going to happen first? So when we get inside this myFlat, I have this flattened array that we have over here. So let's create an empty array first of all. I'm going to add the empty array somewhere over here. Alright, let's consider this is going to be the empty array. So within this array, we are going to add the result of whatever this entire function gives us one by one. Alright, so what happens first is we go into the flattener function and then we loop through these elements. Alright, for const element of array, So the first element is 1. We check if this element is an array or not. We check if array dot is array of element. So 1 is not an array. We're going to go to the else statement and we are going to push the element into the flattened array. Alright, because it's not an array, it's just an element. So we go to the else, we push into the flattened array the first element. This is going to have nothing but 1. Alright, then after that we go to the second element, which is 2. Now 2 is again not going to match this condition because it's not an array, it's an element. So it's again going to be pushed to this flattened array. 2. Then 3 is going to do the same. Since it's an element, we get 3. And then the next element that we get is an array, which is nothing but 4 and 5. So when this is the element, when it says const element of array, the element is 4, 5, it's going to say if array dot is array of element, and this part is going to return true. This part is going to be true because it is an array 4, 5, and it's going to check the depth. So the depth that we have passed over here is 3, right? We have passed in array dot myFlat 3. So you must know that 0 is always false, but every other number 1, 2, 3, 4 and so on is always true. So until this depth is not 0, it is always going to be true. This part is always going to be true. And now since the depth is 3, we have passed 3 over here, so this is also going to be true. So array dot is array is going to return true because the element is an array, and depth is 3, so it's just going to become true and true. So when it becomes true and true, we call this flattener function again. This flattener calls this function again. It passes the element, which is 4, 5, and it passes depth minus 1. So what this means is, I'll just write it over here. I'll write flattener, right, and I'll pass 4, 5, and I'll pass the depth, which is nothing but 2. Right, so this is what's passed to the flattener when we reach 4, 5. Alright, so when that happens, we call flattener again for these parameters, these two parameters. When that happens, what happens next is it again loops through each of these elements for const element of array. So basically what's going to happen now is flattener calls itself again with these two arguments, and the array this time is 4, 5, and there is obviously no array within this array, so this should be pretty easy to dry run. Now remember in our result, so I'll just call this result, nothing but the flattened array. So our flattened array has 1, 2, 3 for now. Then when we called 4, 5, called this function again, and it passed 4, 5 array, and the depth is depth minus 1, which is nothing but 3 minus 1, which is 2. So just so you remember, I'm just going to write over here 3 minus 1. Alright, so when 4, 5 array is sent to this flattener array again, and the depth is 2, it's going to loop through each of those elements of this array. So first element is going to be 4. It's going to see that 4 is not an array, it's just an element, so it's going to put the else statement, and it's going to push within the flattened array. So it's basically going to push 4 within the flattened array, which was obviously global within this myFlat polyfill. So what happens, it's going to do flatten array dot push element, which is 4, and the element is nothing but 4, so it's going to pass 4 over here. It's going to push 4 over here. Then it's going to go to the next element, which is nothing but 5, and then when it reaches 5, it sees that that is also not an array, it's an element, so it pushes it to the flattened array, and we get 5 over here. So now after 5 is pushed, both the elements for this have been executed, so this part is entirely executed. So now what happens is, so this memory space gets cancelled, this is over. Now we go on to the next element, and the next element is nothing but this entire element. So the flattener function that we called for 4, 5 got executed, and it pushed 4, 5 over here within this resultant array, within this flattened array. It got over, it got popped out of the memory space, and then we reach to the next element, which is this complete array. So what happens when we reach here? So we were previously in the third index, now we go to the fourth index, which has this array. So it's again going to check for const element of array. So it checks if array dot is array element, and this element is actually an array. This part is going to be true, and then it's going to check the depth, and depth, as we see over here, was 3, so this is going to be 3. And remember, in the last time we called flattener, we did depth minus 1. We did not decrease the depth variable, we just passed another number to this flattener function, which was depth minus 1. We did not modify depth itself. That's why depth is always going to remain 3, because once the function call that we had made for this got completely executed and popped out of the memory space, then we went back to over here Now this is going to create a new memory space. Now for that memory space, it is going to have the depth of 3, because this is a new memory space and we just pass the depth as a number. We don't modify it. So as I was saying before, when we reach over here, this element is an array, so this part becomes true, and depth is 3, so this also becomes true. So since both these conditions are satisfied, we call flattener again. The next time this is popped out of the memory space, you don't need to worry about this. I can just cross this. So what's going to happen next is we call flattener again, and this time in flattener, what are we going to have? We are going to have nothing but the element is going to be 6, 7, 8, 9, 10, 11, 12. All right, so this should also be closed, and the depth of 2, and this is going to come from 3 minus 1. All right, so this whole element is what we are passing to the entire flattener. So now what's going to happen is it's going to again go to the flattener. The array this time is this part over here. The depth is 2, so it's going to loop through each of these elements. First element is 6, so it sees that 6 is nothing but an element, not an array, so it's just going to push it to the flattened array. So we are going to get 6 over here. Then similarly it's going to do the same for 7. 7 is also just an element. Same for 8. 8 is also just an element, but then it's going to reach another array, and this time in this memory space we already had the depth as 2, and we reach another array. In this for loop we reach another array, so this time it's not going to directly push, it's going to check this condition. It checks if the element is an array, so this element is an array, and the depth, which is 2, the depth is also true, so then it calls flattener again. So this time it's going to call the flattener again, and the flattener is going to have the following parameters, the arguments. Since 6, 7, 8 have been pushed, we reach to this array, so this array is going to be passed to this flattener. Now what's going to happen is we are going to pass this whole array. This is going to be the next element. We have 10, 11, 12, and then after this we pass the depth, and the depth is nothing but depth minus 1. The last depth was 2, this time it's going to become 1. All right, this was nothing but 2 minus 1. That 2 came from over here. All right, so now we are going to perform the same function again for this array over here. So it's going to see 9 first. 9 is nothing but an element, so it's going to be false for this if statement, so that's why it's just going to go to the flattened array dot push, and it's going to push 9 back over here. All right, so now after that it's going to go to the next element in the loop, and the next element is again an array. This array contains 10, 11, 12. So what's going to happen again? The element is an array and depth is 1, which is true again, so it's going to call the flattener function again. When that happens, we are again going to call another flattener, call flattener. This time you guessed it right, we are only going to pass 10, 11 and 12 as the array, and the depth is going to become depth minus 1, which is 0. All right, so then the flattener gets called again. This is going to be nothing but 1 minus 1. We are running out of space, but it should be fine. So now the next array is 10, 11 and 12. So it's going to loop through this 10, 11, 12 again. 10 is nothing but an element, so since this is just one array itself, it's going to see when it loops through each of these elements, it's going to see that 10 is just an element. So we don't care about going within this if statement at all. In fact, it's not going to go within the first if statement at all for any of these elements, because it has no array included within it. So when it sees 10, it's going to push it into the flattened array. So we're going to get 10 here, sees 11, so basically we go to the next element in the for loop, we see 11, and 11 is also going to be pushed because it's not an array, and then we reach to 12, and 12, it's also 12 is an element which is not an array, so we'll go to the else and we'll push it into the flattened array. So 12 is also going to be pushed here, and then this function is going to be over, right? So this is going to be popped out of the memory space, and then it's going to come back here, and since this function had called this, for this got over, this also gets over because all of its loops had been executed. So this also pops out, and this, after this pops out and comes to this flattener function, like this flattener function, all of these loops have also been executed, like all of these loops have also been executed, so this also finally pops out. All right, so once all of these flattener functions have popped out, so all these three flattener functions were called for this one element. just for this one element, as you can see, because first for these three, then this array over here, and then only for this array. So just to show you, first for this entire array, then from 9 to this end of the array, then only for 10, 11 and 12. So that's why we had 3 flattener functions being called. Once these also have been executed, all of these flattener functions are going to be popped out of the memory space. Then that last memory space is still going to be there, which was the initial for loop, which was looping through each of these elements, 1, 2, 3 and so on, and which had reached to this entire array, which had considered this entire element as an array and started this entire chain of loops, basically not loops but function calls. So once all of these have been popped out, all of these have been executed, what it's going to do, it's going to see that all of these elements have been executed for each of these elements, because the last element was nothing but this, right, this entire array, and for that we already called the flattener thrice. We did the recursion and it populated the main flattened array. All of these entire loops have been executed, and once that's done, this function also closes, and then we go to the last line of the code, nothing but return flattened array. And the flattened array over here, as you can see, this flattened array points to this result array that we had created. So this flattened array is going to include all of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So lastly, we just return this flattened array. So this entire array that you see over here, this entire array gets returned. And then lastly, this array.myFlat, which we call, ends up returning this entire array. So when we console log it, we get this entire array logged out in the browser console. And as we had seen over here in the browser, that is exactly what we get. This is the complete dry run of this entire code and the array example that we had created. This is pretty basic recursion, and even if you had a little bit of difficulty to understand the code, I hope you got a clearer picture after I dry run the entire code. And recursion is something that you can only understand properly once you do it yourself. So I suggest you to go through this code by yourself and also try to dry run it the way I did just now, and you're going to get a clearer picture of how this works. And that's actually the only way you can get better at recursion. So basically this is all about how to implement the flat method in JavaScript. And so that's all for the video. And if you enjoyed the explanation in this video, then don't forget to like and subscribe. And as usual, stay tuned for more.